So you realized in the 1920s that you thought the electron was a little particle. In fact, you should describe it in quantum mechanics by a wave function. If you ever took chemistry, if you ever saw those pictures of the orbitals of electrons, etc., that's the wave function of the electron. Soon thereafter, you realize, no, actually, you should be doing field theory, quantum field theory. And so there's a field that the electron is a vibration in. And you're asking what really exists. Well, there's a wave function of that field. So there's like fieldiness on top of fieldiness. And finally, you say that, okay, what if you have like different fields, different particles? Do they each have a wave function? No. There's one wave function for the whole kit and caboodle of them, the wave function of the universe. That's what's real. The wave function of the universe is real.
You know, he's been smoking something.
That's crazy.
You know, where was he before this? Are you just talking this, or is this hypothesized, soon to be experimentally verified?
I encourage all of the listeners out there to check out my paper entitled Reality.
This would be a research paper.
Called Reality as a Vector in Hilbert Space.
Okay.
That's what reality is. So look, first let me explain.
Sure.
Not everyone agrees with the true thing I just said. So there's disagreement because of this fact that physicists
it's your personal truth.
Can't agree on what quantum mechanics really says. So we have this idea that everyone uses in quantum mechanics, Hilbert space, which is the space of all possible imaginable quantum states of the universe. And someone like me, who is a purist, an extremist about this, says we have all possible quantum states. The actual universe is one of them, and it changes with time. Other people will say, no, that's not reality. That's just a tool we use to describe predictions, to, make predictions for experiments. Other people will say that's part of reality, but there's other parts as well. We don't have a consensus on this.